Okay, so we are finishing up the slides on graphing systems of equations. So we are on slide 7, the first one, and we have the same exact slope, different y-intercepts. So this comes out to be no solution. They will never intersect, so it's no solution. Okay, let's go to the other one. I believe we talked about this one. We have negative 3x plus 6 and negative 3x plus 6. It's the same exact line. So if you graph one on top of the other, you'll have infinitely many solutions. Okay, let's go to slide 8. The y equals negative 2/3 x plus 2. And then 2x plus 3y equals 6. Whenever we solve that out, it comes out to the same exact equation, negative 2/3x plus 2. And I can show you that on my composition book. So I solved it out, and I got the same exact equation. Okay, so that's infinitely many. So I went ahead and graphed it. It's infinitely many. Okay, let's look at the next one. We have two equations that we need to solve for y. So I did that, and I'll show you the first one. Y equals negative 2/5 x plus 8/5. And then the other one, y equals 3/2x minus 5/2. So what I think many of y'all found was that it's hard to graph this whenever you have a decimal as your y-intercept. So we're going to use the calculator on this and then find some points to graph. So I want you to get your calculator, whether that's on your computer or your actual calculator. We are going to put in y1. And I'm going to write down the steps here. So we're going to put this in y1 and this one into y2. And then y2. So you should have both of them in there. Okay, so step 1 was plug in equations in y equals. Okay, step 2 is graph. So you should have two equations graphed on there. Okay, see how these correspond, the colors correspond. So the first one's blue. So if I look over here, see how that's blue? So that corresponds to the first one. Second one's red. That corresponds to the second one. Okay, zoom out if you can't see the intersection. If you can see the intersection, then you're good to go for step 3. So this is just important so in case you cannot see that intersection. Okay, so we are going to have the calculator graph the point of intersection by calculating it. So in our options, see we have all these options. We are going to calculate. So that second trace. Which is the calculate button. You've probably used this before. Do y'all remember using this before? No? Okay. And then go to number 5, intersect. Push enter. And it says intersect or first curve. As long as you can see the intersection, you can, so step 4 is enter. Second curve is the second line. So you should have a point on the first line, point on the second. So enter, enter. Then it says guess. So you push enter again. And then it pops out your intersection. So that would be your intersection. So on this one, it is 2.1. Let's go on to the tenths place, so or hundredths place. So it'd be 2.16 and 0.74 is our point of intersection. Seems like an ugly answer, right? It's not a whole number. It's just, it goes on and on. Surprised there's not a way to hit frac. Also, what you could also do, and this will estimate it, it won't get the exact like this one does, but if you just hit the button trace, see how close that is, 2.12 and 0.75, really close. But in order to get the closest approximation or the exact, you would do the second trace, enter, enter, enter. 5, enter, enter, enter. All right, so now we need to graph this. So the best way to graph this on your paper is go to your table of values. And we want to find some points. So see how this is y1, this is y2? So I'm going to do just 3 points for this equation and 3 points for that equation and graph it on the digital interactive notebook. So y, x, y. Really, you only need 2. So let's do 2. So let's see, whole numbers. -1, 2 is with the blue one. And another point would be 4, 0. And then for the other one, for the other line, x, y, that would be your red one. You follow the same x's, but the y's change. So 3, 2 is a good point. And what about 5, 5? See where I'm getting those from the table? Okay, so now we can graph it on the composition book. I mean, on the digital interactive notebook. So let's go over there. And let's plot the first one. Oh, and also you're supposed to have your equations written down here, which I've already gone over what that is. So the first one is -1, 2 on the first line, and then 4, 0. Oh, that looks pretty good. Okay. And then the next one, 3, 2, and 5, 5. Does everything look right? As long as we have 1 point, we can find any points because we would do our slope. So like on this one, we know our slope is -2/5. So if I have this point, I would go down 2/5 to get my next point. and I could continue that same pattern. And then this one is up 3 over 2. So once I have at least 1 point, I would go up 1, 2, 3 over 2. Down 1, 2, 3 over 2. Okay, so now you can see where they intersect. And that's it. So we do need to put a point of intersection right here. I need to bring that to the front. Oh, no, I want to bring that point to the front. Why does it not want to bring it? I'll bring this to the front and change the color to red because that's my point of intersection. And then put this line back. Okay, there we go. So does that look like what we found, which was the 2.16, 0.74? Does that look pretty accurate? A little past 2 and underneath 1. So I'm going to put this right here. Okay, so that is it for the notes for today. You're going to finish the assignments that I had y'all take yesterday, which is solving system of equations by graphing. Make sure you're showing your work and make sure that if you need to solve any of these for y, that you do it on a sheet of paper because there's really not enough room here. And then staple your work to your assignment. You can also use the calculator to check your work, just like I taught you how to graph and then check your intersection point. Okay, so y'all are going to finish that the rest of the class period.